There's this new viral video that's claiming that we are seeing into another universe. It comes from NASA's newest experiment called ANITA, which is looking for answers to some of the biggest questions in physics, and it makes use of one of the most powerful telescopes in the world. But what does it actually do? And is it really showing us another universe? When physicists think about the vastness of space, they mean really, really big, like the observable universe is around 94 billion light-years across. So when you're standing on Earth and you look up at the night sky, all those points of light are unimaginably far away. But even the distances between those points of light seem small compared to the size of the entire universe because space is expanding. As space gets bigger, galaxies move away from each other, and the farther away a galaxy is, the faster it's moving away from us. This discovery in the 1920s led to the idea of the Big Bang theory, which says that the universe began with an unimaginably hot, dense point and has been expanding ever since. But in the 1960s, physicists started wondering, is our universe the only one? Could there be other universes out there? And if so, how could we possibly find them? Well, one idea was that if there were other universes, they would have to have their own light, their own signals, and they'd have to expand too, just like ours. But it wasn't until the late 1990s that physicists had the math to describe what that might look like. In 1999, two scientists came up with a way to describe a universe where space doesn't just expand, but it also oscillates, getting bigger and smaller in a sort of never-ending cycle. They imagined that maybe at some points during these cycles, our universe would overlap with others. So even though these hypothetical universes only take up a tiny amount of space, we would catch a glimpse of them as they pass through ours. The result would be an unusual signal in the cosmic microwave background, or CMB. The CMB is the faint glow left over from the Big Bang. It's the oldest light in the universe and it comes from every direction. It's our universe's ID card telling us something about where it came from and how it evolved over time. If we want to figure out what the early universe was like, it's the perfect thing to study. And over the past few decades, scientists have studied it extensively. They know that the CMB should be evenly distributed in all directions, which makes sense since it comes from all over the sky. But it turns out the CMB isn't perfectly smooth. There are temperature variations of around 1/1,000,000th of a degree. And we think these variations are caused by tiny density variations in the early universe. These small variations grew over time to become the large structures we see today, like galaxies and galaxy clusters. Now, there's another reason why the CMB might not be perfectly smooth. If there are other oscillating universes as the peaks and valleys of those universes line up with ours, we should see a change in the temperature of the CMB. And unlike the density-based variations we talked about before, these variations would show up at a particular location in the sky. So if we were to scan the CMB and find a sudden dip in temperature coming from a particular direction, it would hint at the possibility of other universes. To find these dips, we need a telescope. And the telescope we need needs to be incredibly sensitive. It can't be more than about 1 degree wide, or else it won't be able to resolve the details of the CMB, and it must be extremely cold, or else its own heat will drown out the signal from space. That sounds like a tough set of requirements, and it is, which is why it took almost 20 years for the first experiments to come close to being sensitive enough to test this idea. In 2007, an experiment called Boomerang detected an unexpected dip in the CMB. At first, everyone got very excited. Was this evidence of another universe? But it turned out that the dip could be explained by dust in our own galaxy. And since then, newer and better telescopes have searched for other anomalies in the cosmic microwave background, but haven't found anything yet. Even so, physicists haven't given up on the idea of other universes. They just needed a new approach. Enter ANITA. ANITA stands for the All-Sky Microwave Background Imager, and instead of trying to detect an anomaly in the cosmic microwave background, ANITA looks at a phenomenon known as the cosmic microwave background bispectrum. Let me explain. Remember how I said that the cosmic microwave background should be evenly spread out? That's true overall. But that doesn't mean that it's completely smooth. In fact, the cosmic microwave background has a pattern called the Sachs-Wolf effect, which consists of temperature variations caused by the gravitational pull of matter in the universe. These variations appear as a kind of grain in the cosmic microwave background. But the signal we get from the CMB isn't just the temperature variation itself, it's also affected by the expansion of the universe. As the space between the Earth and the CMB expands, light gets stretched, shifting it toward longer wavelengths and lower energy, which corresponds to cooler temperatures. So the temperature we measure depends on whether the space between the Earth and the CMB is expanding or contracting. This means that if you calculated how much of a temperature variation you'd expect to see based on the distribution of matter, the actual temperature would be a combination of that calculation and the effects of the expansion of the universe. Mathematically, you can calculate this as the sum of three separate signals: the temperature variation due to matter, the effect of the expansion of the universe, and the combination of the two. This mathematical sum is the bispectrum. It tells us how the three-dimensional universe changes from one two-dimensional slice to the next. And it gives us a lot of information about the distribution of matter in the universe and how it's moving. It's also something that's only seen in inflationary universes, so if ANITA can find the bispectrum, it would be strong evidence that our universe went through an inflationary period in the first few seconds after the Big Bang. Inflationary theory is widely accepted among cosmologists because it explains a lot of features of the universe that otherwise would be difficult to explain. Like, it explains the large-scale structure of the universe and why the CMB has the features that it does. So, confirming inflation with ANITA would be huge, but finding the bispectrum is tricky because it's an extremely weak signal. Previous experiments haven't been able to detect it, so now, along comes ANITA. ANITA is a balloon-borne telescope that launched in June 2022 and is currently floating around the globe at 37 kilometers above the surface. At that altitude, it's much colder than the surrounding atmosphere and is therefore much better at detecting faint signals from space. It also has a 10-meter diameter telescope which is over 10 times wider than previous experiments. This allows ANITA to accurately map the bispectrum of the CMB and confirm or deny inflation. But as of right now, it's still collecting data, and we have to wait until February 2024 to get the results. But in the meantime, while we wait, I'm going to go back to enjoying the view of the universe from my couch. Thanks again to Minute Earth for collaborating with us on this video, and thanks to our supporters who make videos like this possible. To learn more about how you can support us, head over to our website.